So we'll be solving partition equal subset sum. This is a standard dynamic programming problem, and the problem statement is that you are given an array and you are going to decide if you are able to divide the array into two subsets, and those two subsets should have equal sum, as the problem statement clearly says. Now, one obvious thing to note here is the sum of the entire array should be an even number. If it's odd, we obviously cannot divide into two equal parts. The other thing to note is that the length of the array is, according to constraints, is very low. That means we might be able to get through it just with the recursive solution, but let's try for this one. We would be needing a sum, and eventually this can be solved using recursion, and we'll be going through with that approach only. So I'll be capturing the sum of the array first. Now clearly if the sum is odd, we'll be just be returning false. Now we would try to build a recursive solution, and for that we would be opting for the take or not take pattern. For that, I'll just create a method. I'll be calling it. I'll be taking the index. Now if I is at the end, I can take a global sum as well. I'll be taking a sum here. Initially that sum would be 0. Now if that index is already at the end of the array, I can keep it as a boolean actually. So let's put it as a boolean. This is equal to I think do I want to do it that way? I'll hmm. You can pass in the total sum as well. Let's pass in the total sum here. Total sum here would be sum of each of the individual elements, which means that or I can calculate it here as well. Probably it's better to keep it, pass it as a parameter. I'll do that. So if I'll pass in the sum here as well, sum is equal to, and this would be total. I'll keep it as a total equal to, and this is total by 2. In that case, we simply return a true. And what would be the cases here? Either I can take or not take, right? Let's take int take. Hmm, not take. Let's let it be boolean. Uh, let that be the function call to. I'm going to be taking, that means I'll go to the next index anyways, and in that sum I'll be incrementing uh, this nums of I, and total remains total. And let's take a not take case. This will be going to the next index, but we'll be passing the same sum. And here, let me also add sum. And by default, we would be returning false. I'm going to be returning false here. Now, if either the take or not take cases return me from the recursion or true, then we should be good. Let's try this out. Instead of if, I'll be returning this value. It has been accepted, which means I would need to optimize this solution. Let's try to see if this already passes. Okay, this already passed, as this is not part of the plan, so eventually it doesn't matter. We're going to optimize this. So if we are trying to store this sum as part of a DP array, this would be 50 times 100. That is, I think, well within our reach. It won't overflow, so we can continue with an regular integer. Now this needs to have the size. Mm, and it would need to store the sum as well. Sum, okay. The max size of the table should be till sum. That's just fine. What about sum plus 1? Hmm. Let's keep it sum plus 1 so that it doesn't overflow at any point. Hmm. Now again, instead of, let's add a check. We would be having it this way. Oh my god, one sec. But here we are assigning that boolean. So instead of that, maybe you can return a 1, which is fine. I'll change the method signatures, and that should be it. Let's see if this works. And it got accepted. So that was the solution.